All right, so here's our first flashcard. On one side of the flashcard, we have y equals sine of x, and I want to find the derivative of sine of x. What is it? Cosine of x. So there you go. How cool is that? How cool is that? Okay, if you want these flashcards, I guess I could email them to you, but you'd have to email me. All right, here's the next one. Yeah, if the derivative of cosine of x is negative sine of x. There we go. Okay, next one. I like these digital flashcards. I did this during my prep period, first period today. What about this one? What is the derivative of tangent of x? Secant squared of x. Good job. What about the next one? What is the derivative of cotangent of x? Negative cosecant squared of x. Good. What is the derivative of cosecant of x? Negative cosecant of x times cotangent of x. There you go. There's Emerson and there's Sasha. Okay, here's the next one. What is the derivative of secant of x? See, what is it again? Secant of x, tangent of x. There we go. The derivative of secant of x is secant of x times tangent of x. What is, this is not a derivative, this is a limit. What is the limit as x approaches 0 of sine of x over x? It's 1. Good job. What is the limit as x approaches infinity of sine of x over x? It is 0. What is the derivative? What is the limit as x approaches infinity of cosine of x over x? It is also 0. Okay, cool. Those were neat. Now, as I said, as we progress through this course, we have other derivative functions. I'm going to add that to our flashcards. We do have a lot. So hopefully you are memorizing the ones that we have, we've seen already. If you wait until the end, right before the AP test to memorize all of them, it's going to be a lot. So let's do this in chunks. All right, so there are some other ideas that we talked about with when we take the derivative, like if I have, this is called the power rule. If my power rule, if I have, that's really crappy, I wrote it, sorry. It's not very nice. If I have y equals a to the power, a is some type of coefficient times x to the power of some exponent n, then the derivative of this is what? A times what? A times n, x, n minus 1. We also talked about the product rule, and the product rule is if I have a function times another function. What is the derivative if I have a function times another function? F of x times the derivative of g of x plus g of x times the derivative of f of x. Yep, I don't know if I have, I think I just squished it in there. There we go. And then we also had what's called the quotient rule. And the quotient rule is when I have a function divided by another function. The derivative of this is going to be what? No, it's not high. Low d high minus high d low over low low. Low d high, d means the derivative of high, which would be f prime of x. So low d high minus high d low, the derivative of low, over low low. Okay, there you go. That's the derivative. Today, the main idea is the chain rule. And the chain rule is what do we do when we have a function that's inside of another function? So we have something like this. I have y equals f of g of x. This is not the same thing as the product rule. This is a function that is nested inside of another function. So I'm going to scroll down here and I'm going to write down, let's go ahead and write the assignment for today is 4.1. Oh, that looks a little too far out. Let's go for 4.1. And all of today is about the chain rule. And the chain rule is this idea when we have a function inside of another function. It should not be confused with the product rule where we have a function times another function. So if I have f of g, so my function is f of g of x, where we have a function nested inside of the other function. We have g of x inside of f of x. Then when we take the derivative of this, we take the derivative of the outside function. So that would just be f prime of g of x. That's taking the derivative of the outside function times the derivative of the inside function. So times the derivative of the inside function, and that's it. That is the chain rule. Let's do an example. Let's say that I have an example like this, where I have y equals, in parentheses, I have, I don't know, 3x minus 2 to the power of 2. Do you recognize an outer function? Yeah, it's just u squared, right? It's this value here squared. That's the outer function. And the inner function is the 3x minus 2, right? We have an outer function, the u squared, and we have the inner function of 3x minus 2. Now, I'm not going to do the chain rule first. I'm going to do this using the power rule by first using some of the skills that we learned in secondary math 2. We are going to expand this. So right now we're not doing any calculus at all. I'm just rewriting this in expanded form. Now that it's expanded, I'm going to distribute. Also a secondary math 2 idea. When I distribute, what do I get? What do we get when we distribute? So I get, 9x squared minus 6x. Okay, now what if I distribute here and here? Minus 6x plus 4. We combine like terms to get y equals 9x squared minus 12x. Move Mr. Hall out of the way, plus 4. If we're going to take the derivative of this, we don't have to do any fancy math. We just do the power rule for each one of the terms. What is the derivative of this term? Louder? 18x, good. The next one? Minus 12. And what about this? Yeah, the derivative of a constant is just 0. So we're left with this as our derivative. Now we're going to use this other method called the chain rule, where we need to recognize that we have a function inside of another function. We have this u squared, and inside of our function, we have this 3x minus 2. Let's review the chain rule. When we have a function nested inside of another function, we take the derivative of the outside function times the derivative of the inside function. So I'm just going to, I'll just cut this, I'll copy it. Copy that, scroll down, drop it in here. We're going to now do the same thing by using the chain rule. Okay, now we do the derivative. So the outside function again is what? U squared. So the derivative of u squared is? Yeah, just 2. So I have 2u. But it was never u. It was 3x minus 2, right? So I'm going to introduce that back in. I have 2 times 3x minus 2. So all I did is I took the derivative of the outside function, leaving the inside function alone. Took the derivative of the outside function times the derivative of the inside function. what is the derivative of the inside function? Yeah, the derivative of 3x minus 2 is just 3. So I'm going to multiply by 3. Now, if I want to clean this up, I suppose I could multiply this 3 times this 2. That would give me 6. We'd have 6. And then I have this 3x minus 2. And then we could distribute. All I'm doing right now is I'm trying to show that it's the same thing. I want to show that it's the same thing as this. And so do you see if I distribute, I'm going to get that? Yeah, we get the same thing. We get, so y prime equals, when I distribute, I get 18x minus 12. We get the same thing. Well, then the question is, why even learn the chain rule? Why not always just distribute and then we have terms, and at that point, just do the power rule for each of the terms? Well, what if you were given a problem like this? What if I was given a problem like this, where I have y equals 3 times x minus, let's do 5x minus 4 to the power of 16. And I want to find the derivative of this. If we expanded, we would have to rewrite all of this as 3 times 5x minus 4 times 5x minus 4 times 5x minus 4. How many of these? Yeah, 16. And then after we're done with that, now we have to distribute all this and this and this. And then we have to distribute here and here and here and here. And then whatever this is, distribute here and here and here and here. And then whatever this is, distribute here. I have to do that all over again. How long is that going to take, do you think? How long? You think? I think it could take an entire day. And the scary thing is that the more computations you have with the math problem, the probability of making a mistake goes up. With each extra computation you have to do, the probability of making a mistake goes up. So that's a lot of work for something that you might not even get the right answer for, because you made a silly mistake. Can you appreciate why the chain rule might be beneficial? Well, let's do the derivative then. How do we do the derivative using the chain rule? Take the derivative of the outside function times the derivative of the inside. Yep. So let's do the derivative of the outside function. What is the outside function? Yeah, that's the derivative of the outside function. 3u to the power of 16. What is the derivative of that? Is it 48? 48 times u to the power of, so u to the power of 15, yeah. Now it wasn't u, it was actually 5x minus 4. So we just took the derivative of the outside function times the derivative of the inside function, which is 5. Yep, there you go. Stop there. You could multiply this to this, but if this is a free response problem, hey, Avril, then just stop. Just stop, you're good. They don't want to, the AP test is not measuring, generally speaking, it does not measure your ability to do arithmetic. They just want you to, they're trying to measure your ability to do calculus. So for a free response question, just stop here, you're done. Okay, let's do another one. Let's say, let's do another example. I want to take, so find, this is my example. Well, now I'm already making some errors. My example is, so I want to find dy dx of y equals sine of x squared plus 3. What's the point of the chain rule? Fernando, why do we have the chain rule? What's the point? It's a tool for what? It's a tool to help us do what? Perfect. Yep. It's to find a function. It's to find the derivative of a function where we have a function inside of another function. That's the point. Do we have a function inside of another function here? What is the outside function first? Louder? Yeah, it's just sine of u. That's the outside function. What's the inside function? X squared plus 3, yeah. And so we're going to do the chain rule. And remember, the chain rule is the derivative of the outside function times the derivative of the inside function. So we're taking the derivative of the outside function, which is what? Yeah, so that's going to, so my derivative is going to be cosine of u, but it wasn't ever u, it was what? X squared plus 3. So we took the derivative of the outside function times the derivative of the inside function. What is the inside function? Yeah, the derivative of the inside function is 2x. So we have 2x. Now here's a question for you. Which one of these quantities in here or expressions is a rotation? A rotation is a measurement of, or an angle, I should say, is a measure of a rotation. Which one of these is the angle? Emerson, any ideas? Well, cosine is always cosine. What is the definition of cosine? Yeah, what's the ratio? Yeah, it's adjacent over the hypotenuse. So when we write cosine, it's always of a perspective of the angle. And so we write cosine of our angle equals the adjacent over hypotenuse. So which one of these quantities is the angle? I'll help you out. It's either this one or this one. Yeah, yep. Which means what is this? It's a length. We have a rotation and a length. These are different. In fact, a lot of times I would just stop here if it was free response, but you're going to see it written, if it was multiple choice, you would see it written like this: 2x times cosine of x squared plus 3. Which means that this is your amplitude. Which is sort of a cool idea that your amplitude is this line, y equals 2x. And then our graph, well, I'm not exactly sure off the top of my head. Let's go. The graph is going to look something like this. Okay. Not that you don't have to graph it. We just need to understand how to find the derivative. What's the point of a derivative? What does a derivative help us calculate? Yeah, it's my instantaneous rate of change or the slope at some value of x. Yep. Okay, let's do another one. Find dy dx of our equation y equals 3x minus 2 to the power of 3. Fernanda, off your phone, please. Do you recognize a function inside of another function? U cubed, yeah. What's the inside function? 3x minus 2, okay. Let's take the derivative of the outside function, which is 3u squared times the derivative of the inside function, which is just 3, but it was never u, it was what? 3x minus 2. Yep, there you go. If it's free response, just stop. Could I multiply this 3 with this 3?
Yes.
Yeah. Could I then distribute? No, you can't. Why not? We can't distribute because even if I have this 9 over here, that's 9 to the power of 1 times 3x minus 2. This is my base to the power of 2. I have different bases, different exponents. I have a rule of exponents that says the same bases and different exponents, I can add the exponents. I have another rule that says if I have different bases, but the same exponent, then I can just multiply the bases and get the same exponent. There is no law that allows me to combine when I have different bases and different exponents. So there's nothing, I can't do anything more than that. Unless I want to distribute. I mean, unless I want to expand this to be 3x minus 2 times 3x minus 2, and then distribute that. Emerson.
If you put it as 3 squared times 3x minus 2.
Oh. Okay, so this is Emerson's suggestion. He says, what if we write this as 3 squared times 3x minus 2? Then we do have a 2. Then we do have a law that allows us to combine those. So what could I do at this point? 3 times 3x minus 2 all squared. Now can I distribute? Yeah, now you can. Now you can. But just stop here. Emerson, good eye. That's cool. That's cool that you saw that. All right, let's do another one. So the same directions, right? We're trying to find dy dx. I'll just say find y prime. How sloppy can I get? Y prime. And I have y equals cosine of x squared plus x. A little bit of think time. Drew. Do you go by Drew or Andrew?
I don't really care.
It doesn't matter. Okay, Drew, did you get it?
Kind of. But
Do-
you
do-
might be wrong.
Do you see an outside function first?
Yeah.
Yeah, it's cosine of u, right? And then the inside function is x squared plus x. Okay. So let's take, Drew, let's take the derivative of the outside function.
The negative sign.
Yeah, negative sine of u. And it's not really u, it's, oops. It is x squared plus x. And then,
And then it's multiplied by 2x.
yeah, multiplied by 2x. Can I distribute this now? Oh, yeah, we missed this part. We missed that part. It's all right, I missed it too. Can I distribute this? Why can't you? Yeah, this is an angle. That's a measure of a rotation. And this is a length. You cannot, these are different units. You cannot distribute. If we wrote this with this in the front, you can see that that is my amplitude and this is my angle. That's how high, right, your graph goes. So you cannot distribute. Okay. Oh, I don't know why I wouldn't leave that. That's a good idea. Just leave that there. It's my length. Okay. Let's do another one. Example. Find dy dx of, Mr. Hall, why are you getting so sloppy? Of y equals secant of tangent of x. This is probably the hardest one I'm going to give you today. What's this method called where you have a function inside of another function and you'd have to take the derivative of it? It's called the chain rule. More think time? He wants more think time. One more think time, okay. Josh, congratulations on your recognition this morning. That was very cool. I'm like, oh, I know that guy. It was very cool. Emerson, do you see a function inside of another function?
Yes.
What is the outside function?
Secant of u.
Yep, inside function. Okay. What is the derivative of secant of u?
Secant of x times tangent of x.
Secant of u times tangent of u. But it wasn't ever u. What was it? Tangent. Okay, so I'll just rewrite that. I'll replace my u's with tangent of x times tangent of x. Does that look right to you? Okay. So are we done? No, we just took the derivative of the outside function times the derivative of the inside function. What is the derivative of the inside function? Louder? Yeah, secant squared of x. Can I clean this up somehow? No, it's all, this is simplified. I can't see how you could simplify this at all. Could I put these together to be tangent squared of x? No, because it's not tangent of x times tangent of x, it's tangent of another tangent inside. So it's not the same thing as that. No. What about these secant squareds? Can I put this secant and this secant together to be secant to the power of 3? No, because my angles are different for the two, so I can't do that. So yeah, it's basically all the way simplified. That's it. Okay. Next one. Riley, do you have a question?
No.
Okay. Move on to another one. Go over a little bit. let's try this one. So find, the only thing I don't like is my notation, right? If you go back down to that problem right here, and I said, find dy dx, I did, it's actually completely acceptable, but it's just not consistent. If I'm saying find dy dx, maybe it would be helpful if I rewrote this, rewriting it as dy dx. That's the only complaint I would have, is that let's just try to be consistent with what it's asking. Okay. Although I'd never mark somebody down for that. Okay, let's go over here. Okay, I want to find. Let's do another dy dx. Find dy dx of y equals 4 times the square root of x squared minus 3x. Kyla, do you see a function inside of a function? What is the outside function? Of you, yeah, no? That is, and I would prefer to rewrite this so that we can use the power rule. Yeah, so we'd have u to the power 1/2. And the inside function is just the x squared minus 3x, right? So Kyla, if I take the derivative of the outside function, what do I get? Two, yeah, because 4, we multiply by the derivative, so 4 times 1/2 would give us our 2. So we have 2 times u to the power of what? Negative 1/2, yeah. And it was never u, it was x squared minus 3, so I'll just add that back. And now take the derivative of the inside function. Minus 3. If I leave it like this, there's a mistake. What's the mistake? Are you guys okay with this? What's wrong with it? Isn't it the derivative of the inside function times the derivative of the outside function? Am I multiplying by the derivative of the inside function? Don't I need parentheses? I need parentheses, otherwise it's wrong. Use parentheses. It's the derivative of the inside, derivative of the outside function times the derivative of the inside function. Actually, the other way works as well. The derivative of the inside function times the derivative of the outside function is still correct. Okay, let's try to be consistent so it's not confusing. Yes. So we have a law that, so the question is how to get rid of the square root. And we have this is our 8th law of exponents. This is the last one, 8th law. So this is not calculus. This is actually more of a secondary math 3, secondary math 2 idea. 8th law of exponents. And the law says that if I have something like, imagine this. Imagine this, I have something like x squared equals 25. How do I solve for this? Take the square root. on both sides, I agree with you. But what if I also took the, raised this to, I don't know, to the power of 1/2? What does this give me? What's that power? What's the power to the power law? Yeah, just x. So that's another way of solving for this. So a square root is the same thing as a fraction exponent. Huh. So we have a law that says if I have the cth root of a to the power of b, I can rewrite this as a to the power of b to the power of 1 over c, which is a to the power of b over c. That's our law. So if this is the 8th law, and the reason why it's an 8th law is because it's been proven to be correct over and over and over again, always. It's always correct. That's what allows us to calculate this by using a 1/2, by using a 1/2 exponent. So this is the square root, which is it's implied that there's a 2 here. And it's also implied that this is to the power of 1 here. So using our law, where we have the cth root of a to the power of b, rewriting this as a to the power of b over c, does that make sense how we take this to this? Yeah, that's how we got rid of the square root. And that allows us, getting rid of the square root allows us to use the power rule, which is really nice. Okay, any other questions? So the question is, should I move this to the denominator and get something like, let me zoom out. Because we have a negative exponent rule, right? If I have a to the power of negative b, I move that to the denominator. I have 1 over a to the power of b. That is one of our other laws of exponents. So I could rewrite this as y prime equals 2 times 2x minus 3 all over x squared minus 3x all under the square root. Yes, no, maybe so. Is that okay? Yeah, that's okay. And in fact, if this was multiple choice, it's more likely that this would be the choice that would be given to you. But when it comes to free response, what did I say about free response? Yeah, don't try to simplify it. I'm concerned that if you try to simplify it and then you make some dumb arithmetic mistake, then that's going to count against you. Just stop right there. It's the same thing. Okay, we good? Yes, no, maybe so. Okay, moving on. Here's another one. Yeah. Okay, fine. Let's find. Here's my next example. I want to find y prime for y equals sine squared of 3x minus 2. Emerson, you find it? Do you see a function inside of a function inside of a function? Do you see a function inside of a function inside of another function? Because I could rewrite this. What does this mean? Does that mean that the angle is squared? It means all of it's squared, right? So that means that I could rewrite this. In fact, that's probably helpful until you get used to it. I'd rewrite this as sine of 3x minus 2 all squared. So what's the outside function? What's the outermost function?
U squared.
Yeah, it's u squared. What's the inside function? Sine of, I don't know, q. What's the inside function? 3x minus 2, yeah. Yep. So we have to do the chain rule twice. Sasha, put it away, please. Thank you. Kathy, what's the derivative of the outside function? Catherine, what's the derivative of the outside function? Isn't this the outside function? Yeah, it's just 2u. Huh? It's just 2u, and u happens to be sine of 3x minus 2. So that's the derivative of the outside function. Are we good with that? Kyle, now we need to take the derivative of the inside function. Kyle, what's the derivative of the inside function right here? Kyle? Yeah, it's cosine. Yeah, cosine of q. So I have times, oops, times cosine of q, but it wasn't really q, it was cosine of this 3x minus 2. Now, what's the derivative of the, what is the derivative of the inside function? It's 3. Can you see anything there? If I wanted to, I could multiply it to the 2. Yeah, just the 3. That's a length. But I'm going to leave it because that's the advice I'm giving you. Don't make things more complicated. If it asks, if it's free response, and they're asking you for the derivative, as soon as you get the derivative, stop. What does it mean? What does it imply when you see a problem like this? What does that mean? Chris, any ideas? Yep. So all this means is take the derivative, right? If I say something like this, if I go d dx equals 3x minus 5, something like that, I'm saying that the derivative is 3x minus 5. Now, if you see the derivative as part of the function, not equals, then it means take the derivative. That this is my function, and I want you to take the derivative of it. In fact, if I have d dx of f of x, that means f prime of x. It's the same thing. Sorry? If I take the derivative of f of x equals f prime of x, it's the same thing. Isn't this how we'd read it? The derivative of f of x is f prime of x. Yep. So we take the derivative of this. How many times do you have to do the chain rule? Well, I just see 2. 1, 2, 3. There's three functions, but you're taking the derivative twice. What's the outermost function? The what's the inner function?
1 plus cosine.
Of a q, yeah. And then what's the innermost function? 2x, yeah. So we'll have to take the derivative, we have to take the chain rule twice. Here's once and here's twice. You want some think time? Emma, do you have it? Do you know how to do it?
Exactly. I mean, I can see like at least 2 functions in there.
Mhm. So our formula would be if I have something like y equals f of g of h of x, then that's going, my derivative is going to be what? Actually, I'll put it underneath. The derivative is going to be what? The derivative of the outside function. 1, 2, 3, one more. Times what? Yeah, the derivative of g, the inside function, times, yeah, the derivative of h of x, yeah. So we take the derivative of the outside function times the derivative of the inside function times the derivative of the inside function. How many times could you do this? Yeah, and that's why we call it the chain rule. Because we could just keep on doing this. It's sort of cool that it works out. Where did this come from? Imagine doing this whole thing where we have the limit as h approaches 0 of 1 plus cosine of 2 times x plus h all squared minus 1 plus cosine of 2x all squared all over h. That's where it comes from. We see this pattern that's been created from that original limits function that we had, which was the birth of calculus. All right. So we're going to start, Emma, we're going to start with u squared.
Yes, well,
What's the derivative using the power rule? What's the derivative of u squared?
right now, I don't know. I always just said that like.
So when we do the power rule, when we have something like y equals a times x to the power of n, what is the power rule? The derivative would be what?
So that's C2.
No, but what's the power rule for this?
Oh, that's a and x to the power of n minus 1.
Nice. Yep. So we're going to do the same thing over here. Our coefficient is 1. So we're going to multiply and we get 2u to the power of, we subtract 1 from the exponent to be 2u to the power of 1. Yeah. So we're going to do 2u to the power of 1, which is, well, redundant. We don't have to do that. It's already implied. And it was never u. it was this mess in here, so I'll just put that in, I'll substitute that back in for you. So I have 1 plus cosine of 2x times the derivative, Emma, of the inside function.
Right, which. Hold it up.
What's the derivative of 1? What?
Isn't there no derivative of that?
Yeah, if the derivative of a constant is 0. So that would be, that's gone, that's 0. And then Emma, the derivative of cosine of q.
I don't remember what that one was.
Isn't it negative sine of q?
Yeah.
Okay. So Emma, you might want to email me for my flashcards.
Yeah.
So then just put it into a file and then you can flip through these and get lots of repetition. Okay, so we're going to take the derivative of 1 is just nothing. And then the derivative of cosine is negative sine. So I'm going to multiply by negative sine of q, but it was never q. It was this 2x. And now times the derivative of the innermost function, which is, Andrew? Yeah, just 2. And there you go. That is my d over dx. Now it equals this derivative equals this. Over here, I'm saying the derivative of this function is what? Are we good? Questions? No hay preguntas? Okay. I'm gonna move over here a little bit. I want to write the equation of a line tangent to, well, that should write down. Okay, here's my example. I want to write the equation of the line tangent to f of x equals the square root of 3x squared minus 2 at the point where x equals 3. Write the equation of the tangent line to f of x equals the square root of 3x squared minus 2 at the point where x equals 3. This feels like a chapter 3 test question, except you have to use the chain rule for this one. Didn't you have problems, test questions on chapter 3, finding the tangent line? What's the equation, the generic equation for a tangent line? Yeah, y equals mx plus b. A tangent line is linear. So we're going to use our linear equation. We have x. What are we missing? Okay, y, how do I get a y? Yeah, plug it into the original equation right here, and that gives me, so my y value equals the square root of 3 times 3 squared minus 2. So that gives me y equals, order of operations, what do we do first? We do the exponents, that gives us what? 9 times, gives us 27 minus 2. 25, so I have the square root of 25, which is 5. So we have so the point of tangency is at 3, 5. Agreed? That's what, at that point, we have this line that goes through just through that one point on our graph. So now what? Yeah, we want to find m. How do we find m? We have to find the derivative. We want to find the derivative, which is going to be what? Do we use the chain rule? Do we have a function inside of a function? What's the outer function? Yeah, it's just going to be the square root of u or u to the power of 1/2, which is what? What's the derivative of that? Yeah, it's going to be 1/2. It's going to give me 1/2 of u to the power of -1/2. But it wasn't u, it was this value here. So I'll plug that in to get my 3x squared minus 2. So when we do the chain rule, I don't like how I just butchered it. When we do the chain rule, we take the derivative of the outside function. Times the derivative of the inside function. What is the derivative of the inside function? 6x. Okay, what do we do? That didn't give us m. What do we need to do to find m? Louder? Do we have to simplify? Yeah, let's just plug in this 3. Let's just plug in the 3. It'll tell us what our slope is. So that's going to give me 1/2 times 3 times 3 squared minus 2 to the power of 1/2 times 6 times 3. What kind of slope does that give me? Where do you start? Order of operations, where do we start? Parentheses. What is this mess here in parentheses? So I have 1/2 times, yeah, we figured that out already over here, right? That's 25. But that's going to be, isn't that because it's a negative exponent, doesn't that give me, isn't this 1 over the square root of 25? Does that look right to you? This is 1 over the square root of 25? Please stop me if it doesn't make sense. Okay, then what about this piece here? In the numerator or denominator? The numerator, I have this 18 times 1, just gives us the 18. So we have 18, oops, wrong tool. 18 times 2 times what? 5. Can this be, so that gives me 18 over 10, which can be simplified to what? 9/5. What is 9/5? That's my slope. So we're going to use our y equals mx plus b because a tangent line is linear. Is that too small? Maybe too small. So I'm going to use, let's write down what we do know. So we have y equals mx plus b. Our m is 9/5. Our x is 3. That's what it gives us at the beginning. Our y is, how did we find the y? I forgot. How did we find the y? How did we find that it was 5? Yeah, we took that 3, plugged it into the original equation. It gave us 5. So that's our y value. I'll plug that into here, 5, and then plus b. How do I solve for b? How do I solve for b? Okay, so that gives us 5 equals 27/5 plus b, okay. When we subtract though, when we subtract fractions, we have to have what? The common denominator. So we're going to multiply by what over here? Yeah, 1 in the form of 5/5. That gives us 25/5 equals 27/5 plus B. So B equals what? -2/5. So our equation then is y equals, our slope was what? 9/5 x, and my B value? -2/5. That is, what did that calculate? The tangent line, yeah, the tangent line where? When x is 3. Let's plug this into Desmos and find out. If anybody's still copying, I'll give you some time. See if that's true. So I'm going to go to Desmos. And I'm going to type in our original equation was at f of x equals squirt. If you want the square root, you type in SQRT, squirt, square root of 3x squared minus 2. And I want to find the tangent line at this point of 3, 5, which is right there. And we found that we calculated the tangent line to be y equals 9/5 x minus 2/5. How did we do? How did we do? Looks good. Right there. Yeah, looks good. Looks good to me too. Okay. Anybody still copying? Everybody's good? Okay. They grab one more thing. This is the last activity. And then we will be finished. Add these to our notes. Okay, let's make sure that we understand the prompt. It says we have a function f. It tells us right here, it says graph of f of x, and g over here, g of x is here. So let f and g be functions defined below. They both, to me, look cubic. And then it says let h of x be f of g of x. So we have an internal function. We have a function inside of another function. We're taking this f function here and plugging it into our g function here. Everybody understand the prompt? Okay, here is our first question. I want to evaluate where is h of -2, h of 1, and h of 2. Are you confused with what it's asking? Should we do the first one together? Order of operations, what do we do first? Parentheses. So if h of x equals f of g of x, then I'm really, when I'm trying to figure out what h of -2 is, what I'm really trying to figure out is f of g of -2. So let's just look at this piece right here. What is that? What is g of -2? What does the -2 represent? Is that my x or my y? It's your x. In parentheses here, I have an x, and that x has been replaced with a -2, implying that the -2 is my x. Now I'm trying to find g of -2, so which function do I use, the first one or the second one? The second one. So for the second one, I'm going to go, this is my x-axis right here, I'm going to go over 1, 2. Is that about where -2 is? What's the y? 1, 2, 3, 4. Yeah, it looks like it's 4 to me. It looks like it's 4. So that means to me that we then have f of 4. If this is 4, then now we have f of 4. How do we find f of 4? Which function do I use? The first one or the second one? The first one, f of 4. F is my, 4 is my what? My x value. So we're going to go across the x-axis. 1, 2, 3, 4. Where's y? Louder? I can't hear you. Louder. So is it 2? Negative 2? Does that look right to you? About negative 2? So the answer for that one is negative 2. It's the same? What? Yeah, well. So we're getting. So h of negative 2 is negative 2. Okay. What about h of 1? Do you want to do another one together, or do you want to try to do these on your own? Want to do another one together? Yes. Okay. Let's. I don't know if you said yes or no. Yes. Yes. Okay. So if I'm trying to find h of 1, and h of x is f of x, is f of g of x, then if I'm trying to find h of 1, I'm trying to find f of g of 1. Agreed? So what do we do first? We do g of 1. What is g of 1? It is 0. G of, this is my x-axis. G of 1, it's right there. It's 0. So I'm trying to find now f of 0. What is f of 0? It's 0. F of 0 is 0. We're right there. So the answer is, for this one, is 0. H of 1 is 0. You want to try to do the next one on your own? Okay. I'm trying to find h of 2. I'm trying to find h of 2. Sasha, what'd you get? Yeah, that's what I got as well. I got 6. Yep. So if I'm trying to find h, if I'm trying to find h of 2, then that's the same thing as f of g of 2. And so I'm going to do the innermost function first, g of 2. So here's my g function here. I'm going to move over on the x-axis twice, 1, 2. And my graph is down here, 1, 2 right here. So it looks like negative 2. So if now I'm trying to find f of negative 2, because that's what f of 2 was. So f of negative 2 is my x value. So I'm going, 1, 2, negative 2. And then where's my y value? 1, 2, 3, 4, 5, 6. I think 6 is a good guess that the answer should be 6. So h of 2 equals, not negative, it equals 6. Did we do any calculus just now? Why did we not do any calculus? We didn't do any slopes at all. What was this? That's secondary math 3. This concept is a secondary math 3 idea. Now I want to move down further. If you look down here, is this calculus? Yeah, that is calculus. I want to find h prime of negative 1. I want to find h prime of negative 1. I want to find h prime of negative 1. How in the world do I do that? Do we have to do the chain rule? Don't we have to do the chain rule? if our function is f of g, if h of x is f of g of x, and I want to find the derivative of that, then what do I have to find? If h of x is f of g of x, oops, where's my x? What's my derivative? What's the derivative?
It's the derivative of f of g of x. minus the derivative of g of x.
G prime of x?
Right.
Yeah, the derivative of the outside function times the derivative of the inside function. And since I want to find the derivative when x is -1, and then it just wants me to know whether it's positive, negative, or 0. So I'm going to use this and just plug in -1. So I have f prime of g of -1 times g prime of -1. How in the world would I do that? How in the world would I do this? Well, okay, so what does a derivative mean? It's the instantaneous rate of change. All right, so let's go down here. All I want to know I just want to know whether it's positive, negative, or 0. Okay, so let's look at this piece here. That is the derivative of g of -1. Let's use our g function. We go over to x is -1. What's my slope? It's negative. So this first piece here is negative. So I'm going to use a different color. That is negative. Now let's do this piece here. Is that asking for a slope? Is that asking for a slope right here? No, it's just a value. That's my y value. So let's look at g. What is g of -1? What is g of -1? This 1, 2, 3. It's hard to tell. 3, maybe 3.5. 3.5. Okay, 3.5. So now I want to find f of prime of 3.5. F prime of 3.5, which is what? A slope. F prime. So I want to find here. I'm going to go over to 3.5. Positive or negative? Positive. Yeah. 1, 2, 3, and a little bit more and a half somewhere here. What's the slope? It's negative. What is a negative times a negative? So so my slope is going to be what? At h prime of -1, my slope is going to be what? Positive. Do you want to do that again? Would it help if we did that same problem again? Want to do it again? No? Yes? Nobody wants to talk? What's that? Sasha doesn't want to talk. All right. So that one is calculus. All right, last one says estimate the sign of h prime of -2, h prime of 1, and h prime of 2. So we're doing the same thing, estimate the sign. So I want to know whether is this going to be positive, negative, or nothing. I thought we didn't calculate it. So we're doing the same thing that we did up here. So I want to find, so we're trying to find out, I'll just, actually, maybe it'd be helpful if I just did this again so that we can see everything together. I'm trying to find this last part here. Does that help? Okay. Do you want some think time? Or do you want me to do one of these together? Do one together. All right. So we need to know if our h of x is f of g of x, then h prime of x is what? How do we take the derivative using the chain rule? F prime of g of x times g prime of x. Yep. Okay. So now we're just trying to find this for, so h prime of -2 is f primed of g of -2 times g prime of -2. So where do we start? Yeah, let's do, oh, this one here. Okay, let's figure that out. So what is it? What's g prime of -2? Yeah, to me, it looks like a 0. So here's, I'm using my g function, g prime of -2, 1, 2, what's the slope? It looks to me like we have a horizontal tangent line. It looks like the slope is 0. So if this is 0, I'm guessing since we're multiplying, then what happens to all of this? It's 0. So h prime -2 is what? 0. So that'll be, this will be 0. All right, let's do the same thing for 1. I want to find, we already have our equation for the derivative. So we're trying to find h prime of 1, which is f prime of g of 1 times g prime of 1. What do we do first? G prime of 1. What is g prime of 1? It's a negative slope. G prime of 1 right here, we have a negative slope. So that's going to be negative. So this one is negative. What about this? What's g of 1? G of 1 is 0. And so I'm trying to find f prime of 0. If this is 0, then I'm trying to find f prime of 0. I'm trying to find the slope when x is 0. What is the slope? What is f prime of 0? What is it? Yeah, it looks like my slope here is 0. So so this would be 0, which means then that this is what? It's 0 as well. Do you want to try the last one on your own? Okay, I'm trying to find h prime of 2. H prime of 2. Trying to find h prime of 2. See you, Eleanor. Have a good weekend. Did we rewrite our equation? Here, this is what we need to have this, right? Emerson, are you lost? Okay. Emerson, do you know what the answer is?
I think it's positive.
It's positive. I actually haven't figured it out yet, so I don't know. It is positive?
Yeah.
Anybody need more time? We're good? Okay, let's see. So I have Emerson and Riley that both say it's positive, and I actually don't know because I didn't calculate it. So if I'm trying to find h prime of 2, then that means that this is 2 and this is 2 here. So I'm just gonna, I don't know. And so what am I going to calculate first? You want to do g prime of 2? Okay, g prime of 2. So here's our g function, 1, 2. What's my slope? It is negative. That is negative. All right. Where do we start with this one? Find g of 2. G of 2 is what? Negative 2. So I'm trying to find f prime of 2, of negative 2. Okay, because, yeah, so G of 2 is G of 2 is -2. And so I'm trying to find F prime of -2, which is what? It is negative. That is a negative slope right there. So this part here is negative. What is a negative times a negative? A positive. So that one here, this, where is it? That here is positive.